enough distractions. Let's get to the meat of the program here and look at advent of code. Yesterday we finished 4, 5, and 6. So, you see, there it is. Let's move bacon back. Tests, and if we run it, that was yesterday's run. Perfect. Okay, so, right, let's take a look at what the problem is. Advent of code 2016, day 7. While snooping around a local network of EBHQ, Easter Bunny headquarters, right. You compile a list of IP addresses. They're IPv7, of course. IPv6 is much too limited. You'd like to figure out which IPs to support. TLS, transport layer snooping. You'd like to figure out which IPs support TLS. An IP supports TLS if it has an autonomous bridge bypass annotation, or ABBA. An ABBA is any 4-character sequence which consists of a pair of 2 different characters followed by the reverse of that pair, such as XYYX or ABBA. However, the IP also must not have an ABBA with any hypernet sequences which are contained by square brackets. For example, this supports TLS because there's an ABBA outside the brackets. I guess that's the bracketed part. This does not support TLS because BDDB is inside brackets, even though XYYX is outside. All right, so this seems like a fairly straightforward. We write a little filter. It doesn't seem too hard, he says. So let's add 7 here. Let's add 7 here. 7 here. And 7 here. And then we do this. 2016, day 07. And then we should get 2 unsolveds for day 7. Perfect. Okay, so I think the easiest thing to do, let's get our input. $2,000 lines. Okay. I got to fix my script to do that. Let's take a look at them. Oh, they're kind of long. Not too bad. Are there any nested brackets, I wonder? Like, is there a bracket within a bracket? I don't see any, but it doesn't mean there aren't any here. How would we find that out? I guess we could say search for open bracket, right? We could say search for open bracket. Oops. Open bracket. Followed by any number of non-open bracket, non-closed bracket characters. Followed by another open bracket. And that's not found. Okay. But it looks like we can have multiple closed brackets inside. I can see on this line here, there's 2 sections that are inside, what do they call it? The hypernet sequence. Okay. So these are the non-hypernet sequences, and these are the hypernet sequences. Okay. So that seems like it should be fairly straightforward. What we can do is just break it into the different pieces and then do the searching within each piece and say if there's a ABBA inside, then it's definitely does not support TLS. And then we can look at all those sequences outside and see if they have the ABBA pattern, and if any one of them does, then it supports TLS. I think that's the way to do it. So let's see if we can just write a little function, supports TLS, and it just takes a string, IP string, and it returns a bool of whether or not it supports TLS. Oh, AAAA does not support TLS because AAAA is invalid. Got it. So I think what we can do is just create 2 vectors. Would that be the simplest thing? The address vector. And we can create a hypervector. And then we can just split on open bracket. Let's just do false here, because what I want to do now is just write some tests. Test. Supports. And then we can just say assert bang supports TLS, and then we just give it this string. And this test should fail because it's returning false all the time. So if I do, oh, cannot infer type. Yeah, okay, that's fair. Let's just do that for now. Okay, so let's split up the string into the hyper versus the non-hyper and see what that shows us. So IP, I guess we can do a split once. Let left rest equals IP.split once on an open bracket, unwrap, and these should be stirs. Yep. Then we can say the address push left, and then I guess just for now, let's just print these out. Println left equals left, and right equals right. And run that. Oh, not right. Rest. Okay, yeah, so we have ABBA and then MNOP close bracket QRST. So now we want to split on all the close brackets. Or because we can have multiple, right? We can split on the open brackets and then just split the next thing into closed brackets, and it'll give us the outers and the inners. So yeah, so we say push left, and then we can say for or while let some left rest. Yeah, this will be the hybrid thing now. Left and rest equals IP.split. Or is that for left rest in IP.split? No, it doesn't work that way. It still doesn't work that way. I thought this was an iterator. Let's find out. Yeah, it's a split. So for left rest in iter. Next. Oh, while, yeah, iter next. Yeah, so while let some left right equals iter next. Does that work? Still unknown. Oh, what am I doing wrong? Oh, maybe it needs to be mutable. No. Okay, let's take a look at the compilation here. Oh, expected stir found tuple. I thought, oh right, each one is going to be let's call this a segment. There we go. Okay, while let some seg equals index. Geez. So now the segment is going to look like this. So we're going to split on the open bracket. That inside, outside equal seg dot split once of that unwrap. And those should be strings. So then we say hyper dot push inside and adder dot push outside. And then when we're done, we should see the whole thing. Hyper adder equals adder, hyper equals hyper. Okay, let's see if that builds. Oh, we're not using rest here. This should be rest. Thank you for letting me know. Okay, so yeah, so this got split up. We have ABBA and QRST, which are outside, and MNOP, which is inside. All right, so now we just need to look at the segments themselves. So in the hyper segment, we mustn't have a sequence like this, an ABBA sequence. And one of the adders has to have it, and none of the hypers has to have it. Okay, so for H in hyper, should we just create a has sequence? Has ABBA, if has ABBA, H, and return false, because we're done. And then for A in adder, if has ABBA, A, return true. And we don't need that anymore. And now we just need to write has ABBA. So what's the best way to do this? For C in S dot chars? No, because I want to be able to index. So I can just say let ch as a vec of chars is equal to s dot chars dot collect. And then we can just say for index in 0 dot dot ch dot len minus minus 4, right? Because we don't want to go too far. If ch of index is equal to, so we're looking here, we can look 0 and 1, 2, and 3. So if ch of index is equal to ch of index plus 3, and ch of index plus 1 is equal to ch of index plus 2, then we found a sequence, return true. And that fails. It's not failing here though, because I need to do a cargo clean and then rebuild. Okay. Expected bool found bracket. Oh, right. So if we go through all the whole thing, we need to return false. It doesn't have ABBA. Okay. So this failed. It's supposed to find that it the first pattern should work, right? Println checking H and checking A. Let's see what it says. Okay, so it should have returned true here. So has ABBA is failing. Okay. So we can test has ABBA. Test has ABBA works. I should have done this before, right? Has ABBA, ABBA. So that failed. So that's the test that's failing. It has ABBA though. Oh, it's going, okay. I'm off by 1. There we go. Okay, now the tests are passing. Right, so let's do the other sequences. Make sure we got them right. Copy. Test. FN does not support. Bang supports TLS. Oh, I forgot to hit copy. We still have 3 warnings. What are the warnings? Oh, because we're not using these yet. Right. Okay, so that one works. Let's do this one. Copy. And this does not support. Must be different. So supports TLS. This. Ooh, that failed. Okay. Oh, right. Must be different. I need to add another check here. If CHIDX is equal to CHIDX plus 1, then continue. Right, because we don't want these 2 characters to be equal. Right? Yeah. Okay. Okay, that passes, and then we have one more. And this is like kind of in the middle, so this just verifies that we can actually hit it at the middle there. And actually, I want to do one more test beyond that middle one. Middle works. I also want to test the end. Supports TLS, because we found a bug on the other one, but that didn't work. So let's just double check that. And this supports TLS, so that should pass. And it does. And then our final test, as one that I'm gonna make up, end works. And then say this supports TLS. We'll do a bracket here, and then ABBA. And that should pass. And it does. Okay, so I think we're ready. Parsing is very simple. It's just an array of IP adder, vec string, and then we just open the file. Self IP adder equals AOC lib read. I've forgotten what it's called now. Read file, read string, 606. Oh, we didn't do it there. Oh yeah, we did. Read lines. Input 2016-07.text. Oh, and then we have to initialize it. IP adder vec new. And then run. Oh, right. So we're parsing it. Now we need to solve it. Okay, so all it is we just need to look self IP adder. And then we just want to iter and filter on any IP where IP supports TLS. And then we just need to count. That's running more slowly than I thought it would. Oh, get rid of all the checkings. Let's try again. 105. Let's see if that's the right answer. It is! Huzzah! We're 1 gold star closer to fixing the sleigh. Git status. Git add input. Git commit -m 2016 day 7 input. Oh, okay. I knew there was a way to do it. Let's just check. Clippy should have warned me, and it does. And now we save it here. And this doesn't need to be mutable. And can I just do this then? I can, and it should still say 105. It does. Okay. There we go. Git add source, git commit -m 2016 day 7 part 1. Easy peasy, lemon squeezy. All right, so next up is part 2. You would also like to know which IPs support SSL, super secret listening. IP supports SSL if it has an area broadcast accessor or ABA anywhere in the SuperNet sequences outside any square bracketed sections, and a corresponding byte allocation block or BAB anywhere in the HyperNet sequences. ABA is any 3-character sequence which consists of the same character twice with a different character in between them. Okay. So let's write a support SSL, but it looks like I think we need to refactor. Instead of just having these things, I think we need to create an IP adder struct. Struct IP adder, which contains an adder vector, I guess string, and hypervector. And then in the parse, we don't do this. We say for IP in, and then we're just going to refactor the split code that we just did. And that'll go here. And then instead of saying adder.push, we'll say self.adder.push and self.hyper.push and self.adder.push. Like that. Okay, and now it'll be available to parts 1 and 2. And also it means what we can do is write or implement supports TLS on IP adder. So we can say impl and just make this self. And just go self hyper and self.adder. And then close bracket here. And then we have to change all of our tests. That's a little annoying, but okay. I guess we should create a new. Oh, that's what we should do, right? New from string self. And that's what this should do. Instead of in the parsing code, we should do it here. Because this should be a vec of IP adder, right? And then what we do is we say self dot IP adder dot push of IP adder new IP. Like that. And this should be IP. Yeah, that should do the trick. We still need to, oh, it has ABBA, can still be outside, but we should move it inside. Oh, right, and now the tests all need to change. Let's see if this builds first. It does not. Oh, because I need to check self IP adder iter IP.supports TLS. Oh, that means I have to take it out of the argument. No, I did. Okay. Oh, and then, okay, yep, this needs these things here. And then this becomes a self adder hyper. Oh, so we can do that, right? Yep. Expected struct. Oh, we have to, these all have to be two-stringed because we have to clone them now. Oh. Okay, yeah, we can just do that, right? And now moved. Oh, we don't want to move anything. Okay. There we go. Did we still get 105? We still get 105. Okay. So that refactor worked well. Let's commit this change. Should we make this inside, or I guess it doesn't matter. Oh, before we do that, we need to make sure our tests work. So we have to fix all the tests. So can I say IP adder ::new supports TLS? Will that work? This is line 98. Yeah, line 98. Okay, let's see what happens. Yeah, okay, so I fixed that. So we can do the same thing here. IP adder new. I'll just change all these guys. And then we'll come back here and then just add a dot supports TLS to each one of these. That's not too bad. Let's see if that fixes all the tests. All right, all the tests pass. Let's see if Clippy's happy. Clippy's not happy. Change this to H. And run to get 105, and we're good. Okay, so git commit-am refactor for part 2. Because now in part 2, we're going to do a similar thing, except instead of has ABBA, it's going to has ABA. Let's read this carefully here. Make sure I'm doing it right. A corresponding BAB is the same characters, but in reverse positions. Oh, okay. So we need to look inside or outside. Look at all the outside addresses to see if there's a ABA sequence. And if there is an ABA sequence, then we have to look in the inside and say, does that sequence exist? Okay. So has ABA is not going to return true or false. It's going to return an option string, which is going to have the BAB sequence. And then we can just search for that BAB sequence inside the hyper addresses. Okay, that should be pretty good, right? So we can look for each one. Let th vecchar schars collect. I guess we can just store it that way. That's fine. And then for idx in 0.chlen -2. If ch idx is equal to ch idx plus 2 and chidx is not equal to chidx plus 1, that means we have an ABA sequence, and now I want to return a string with that sequence in it. So I can say return sum chidx plus 1, comma, chidx, comma, chidx plus 1. Say, can I do a collect back string? I don't know if I can do that. These are all chars. None. Oh, there might be more than one ABA sequence in there. So we don't want to just look for the first one, right? We might have like ABA IOI, right? And then inside our hyper thing is an OIO, right? So I don't want to just look for the first thing and return it. We actually want to look at all of the possible sequences. So I could write an iterator, or we could just put the loop in here. FN supports SSL self bool. So let's just put this in here. And get rid of the has ABA. What does not like about this? Oh, we don't want to return that. We want to, if this is true, then we have the string actually we wanted to create. Let check equals this. And this isn't, yeah, it's an unknown. What's going wrong here? Because it's not letting me format, which means that there's a compilation error. Oh, yes, there is right there. There, now it formats. Okay, but can I do that? Self. Oh, we have to go for each, right? For A in self adder. All right, throw another one of those in there. A. And we can, okay, yeah, so we can't collect. We can't collect this way. But there should be a way to can we do iter collect? You can't collect it from, oh, so can this, no. Yeah, you should be able to build a string from chars, right? Unless, no, it doesn't make a difference. Or maybe, can I just create a string? Oh, okay. And then, can I get rid of this vec? Yes. And does this need to be into? No, it does not need to be into. Okay, so now we have something to check. So now we're going to loop over all the hyper things, h in self hyper. And then we can just do a find, right? We can say h dot find, check. If we find it, then we're done. We found a valid SSL sequence, right? Nope, can't do that. Expected implementer of trait pattern required by bound introduced to this call. What type is check? Check is a string. Let's take a look at find. H is a string as well. Let's take a quick look at the Rust string find. What's the API for this? Negvorsa says, what about creating XYX from, what about creating YXY from XYX and looking for it? Yeah, so that's what I'm doing. If you look at the code, I'll show you in a second. Let me just look here. So find. Here's find. Find takes a pattern. Pattern can be stir, char, a slice of chars, or a function or closure that determines if a character oh, it could be a slice of chars. We can just build the slice. We don't need to do this business here. Right? This is a slice of chars. And I should be able to do that. Right, so the way this is working is, it's not working yet, but expected bool found an enum option is sum. Yeah, okay. So this is saying if character 0 matches character 2 and character 0 does not match character 1, then we have the sequence. So I'm building the sequence of the flipped around thing. So 1, 0, 1. Right, so if we find a character sequence of ABA, right, index 0 is A, index 2 is A, index 0 is A, and index 2 is index 1 is B. So that matches that pattern. Then I'm building B, A, B out of it, and then doing a find on that. But we need to do some testing now, see if this works. So let's grab this. Oops, don't need that. Test supports SSL. And we can just say IP adder new paste supports SSL. And let's run a test here. Test passes. Let's copy this. This does not support SSL. No SSL. You're welcome, Negvorsa, anytime. I'm always happy to explain my brilliance to anybody. Sorry. IP adder new. This supports SSL, except it doesn't. So we have to say that. And it fails. Okay, let's find out why. This should not support SSL, but we're returning true for some reason. So let's figure out why. Hfind check. So println found check in H. Found YXY in XYX. Okay, so obviously slice of char is not working the way we expected. Let's make it a string. Can we say as stir? We cannot. Was it saying help there's a similar, oh, as pointer. Yeah, no, I don't want to convert it to a pointer. But we can say into collect string as stir. That's a little messier, but oh, iter, not into. This creates a temporary which is freed while still in use. Brilliant. Okay. Check stir this, and then we can just say check stir as stir. I guess we didn't need to say stir here. Ah, okay, so that passes the test. Very good. And then let's write this test. This supports SSL. End check. right? Because it's checking the string at the end here, IP adder. So it's going backwards. In other words, it's finding this EKE and finding KEK in the hyper list. So that should pass. It does. And then this supports SSL. ZIZ has no corresponding AZA, but ZBZ does have BZB, even though it's overlapping. So let's call this the overlap test. IP adder, new, supports SSL. Okay, and that test passes, so let's flip over to the run page here and go up and actually use the code. So it's basically the same exact code here, except instead of supports TLS, supports SSL. Oops, and we got to get rid of this found business. 258. What do you think? That's the right answer. Huzzah. Okay, so that was day 7. Day 7, part 2. Brilliant. Of course not. Let's see what we got. Use contains. Oh, okay. Can we do that without doing the as stir? Apparently not. Can I do this? Yes. Okay, that's better than saying as stir, I think. And it should still say 258, and it does. Okay, good. Wish there were a cleaner way to do this business, but I think we're all right. This is just example. Yep. All right, we're good. The only thing I was thinking of, so let's go back, is each one of these could just be a vector of chars, right? So we could just do a vec char here, because we're converting it for both part A and part B. Wait a minute. Oh yeah, so it has ABBA needs this thing here, and this also needs the same vector for the addresses. So that would be one simplification, I guess. But I'm not gonna worry about it. Commit -am day 7 part 2. All right. Not bad. Let's take a quick peek at 8.